Today we are going to talk about how to compare the metal reactivity with oxygen. And this four kind of metal is the focus of today, which are sodium, zinc, iron, and copper. So first of all, I would like you to write down the chemical equation of this four metal first. I think you should know it. So for sodium is Na, and Fe and Cu. Remember to write the second letter in small letter, because if it is in capital letter, it will represent another type of element. So underneath here is the general equation when metal react with oxygen. It will produce metal oxides. So it is IDEN here, which is this three letter just represent a kind of ion. So what is the ion? Yeah, this is O2 minus. This is oxide ion. So here you can see that metal oxide is an ionic compound, and O2, which is the oxygen gas molecule, it is a molecule, right? So for molecule, it is linked by covalent bond. And for ionic compound, it is linked by ionic bond, right? So I hope that I hope that you follow my pace to write down the notes here, so that you can follow my teaching in this lesson. Okay. So today's focus is to talk about how to compare the reactivity of the metals. Can you give some suggestions here? Yes. So can you elaborate more? Okay, so let's see your suggestions is possible after we have go through the lesson, okay? So I hope that in school, your teacher should teach you some experimental method to distinguish, to compare the reactivity of metals. So in this lesson, I hope I can give you more explanation to understand the principle of the experiments your teachers have taught in school, okay? So let's talk about how to store the metal first. So here, we talk about the storage of sodium. Just look at this picture first. So in this large rock, actually is sodium. Can you describe the appearance of this sodium first? Yes, it is in gray. You can see that it is not shiny. Yeah, it is dull. And for the freshly cut part here, it is bright, right? And golden in color. So can you explain the difference? Just guess it. Why will be the two different color right here? Yes, you think it is oxidized. Actually, you can refer the equation here. Yeah. So when sodium, the metal here is sodium, it reacts with oxygen, it will produce metal oxide, and actually it is the sodium oxide, which is the product. Sodium oxide is the substance that turns it to gray in color. So can you write down the equation of sodium oxide here? Yes, sodium oxide. The equation is Na2O. Yeah, so here it just describe it more. The surface will turn to dull when freshly cut because of the highly reactivity to oxygen. So after you have understand this reason, so what way will you suggest to store sodium? Okay, you can just compare when you store sodium normally in just maybe a sealed box or compare sealed box, what would it happen? Yeah, because a sealed box, it is easily contact with air, so it will be oxidized. So is there any method that can prevent the sodium gets oxidized? Store it. Yeah, so here it's give it a method, give it a suggestion that store it in a paraffin oil, because in paraffin oil it will isolate sodium from air so that it will not be oxidized. Okay, so how about the other 3 types of metal? How will we store it? Maybe just normally store them in a box, right? Without any special treatment. So you can see that the difference of storage of sodium and the 3 metals. For sodium, we store it in paraffin oil. For the 3 metals, we just store it normally. So actually you can see that sodium is a reactive metal compared with the 3 other metal, and it is easily reacts with oxygen. So let's talk about another case. So when the metal burned here, why we will use burning to compare the 4 metals? Just consider what is the factor of burning. What is the 3 major factors? You should know that. 3 major factors of burning. Yes, it is oxygen gas, the high temperature, and fuel. So in these 3 factors, what do you think that it is the main key point for the comparison? Yes, it should be the high temperature right here, because high temperature can increase the rate of reaction, right? So when we increase the rate of reaction of the experiment, we can quickly to see that what will happen when the metal react with oxygen gas. So understand here? Yes, because the high temperature will increase the rate of reaction, so we can see the result more quickly here. Yeah. So here, actually, this kind of picture and product name you can see in the textbook. Like in here, we compare sodium, zinc, iron, and copper. These 4 types of metal. So can you write the equation when the 4 metals react with oxygen? Yeah, just write it beneath here. Just write down here. Yeah. Just remember that the equation should be in balanced form, okay? I can see that you normally have written down all the equations, so let's get through it together. For sodium, it is Na with O2, so the product is sodium oxide. So how to balance the equation? You can see that both sides, the number of the reactant and product is not equal. So yeah, we need to focus on the O, on oxygen, because it needs to exist in twins, not only single. It needs to exist in 2. Okay, so we need to focus on O2 here first. So in the reactant part, it is 2 O atom here, but in the product part, it is only 1 O. So we need to double the product. So about N, it can exist in single form, so we can add any number in front of it. So for product side, we have 4 Na, so we add 4 in front of it. And for sodium, for zinc and oxygen. Okay, let's write all the reactant and product first. Here we also focus on oxygen gas first because oxygen gas should exist in twins form, okay? So for O here, we have 2 O atom here, so we need to double the O in product also. So we have 2 things here. So reactant part also we need to double the number of things here. So for iron, okay, for iron part, that's a tricky part here because there are 2 forms of ion of iron. Okay, so we have Fe2 plus and Fe3 plus here. So for this reaction, we would take in count of the 3 plus ion, okay? So here we've Fe and O2 we got. So we need to balance the reactant first, okay? So it should be, yeah, I've also seen you written down. So it should be Fe2O3. So in this case, how we balance the equation? So we need first we need to take account into the twin form molecule, which is the oxygen gas. So in the reactant part, we have 2 O atoms, and the product part, we have 3 O atoms. So how to deal with it? Yes, we need to find the common multiple of 2 and 3, which is 6. Okay, so for 3 times 2 is 6. So we double the product. So for reactant part, which is the oxygen gas, yes, 2 times 3 is 6. So 3 oxygen gas here. So about the iron, yes, we have 4 iron here, so write 4 here. So for copper, it should be much easier. Here, so how to balance this equation? So 2 O atom in reactant part, so 2 O atom in the product part, and for copper, just the same number, which is 2. Okay, so the reaction with oxygen gas, we can see that for sodium, golden yellow flame with white powder, and same, which will produce some powder and intense white light here. Yeah, you can see the intense white light actually will be seen. And iron, we will see yellow sparks with some black solid. And for copper, we will see the bluish green flame, and the surface will turn to black. So actually, where is the oxide? Where is the metal oxide? It will exist in solid form. So actually, the powder is the metal oxide, like the white powder for sodium, this powder for zinc, and the black solid for iron, and the copper oxide will turn the surface to black. So here there is some video clips that I would like to show to you actually how is the experiment to be carried out. So let's take a look with this. First we see sodium with oxygen.
Heat sodium in a spoon. Plunge it into a jar of oxygen. It burns to form the very stable compound sodium oxide.
Actually, you can see that the white part is the sodium oxide, and you can see the bright golden yellow flame when it is burned, when the sodium is burned. Okay, so this is the experiment and what you will see when sodium is burned with oxygen. So then now let's see how zinc will react when burning. Yeah, you can see the intense white light. Sometimes it will be some sparks. Okay, so that is the reaction. And let's see how iron will react.
Iron is a silvery metal. Here we see it in the form of steel wool. We're going to burn some iron in oxygen. We first ignite it. Notice the color of, it's not really a flame, it's sparks formed when it ignites. So heat it with the Bunsen burner. Notice the orange sparks that fly around. Plunge it into the oxygen, much clearer orange color, and that reacts with oxygen to form iron oxide.
Okay, so that is the reaction. Okay, so how about copper? So let's see it.
In this experiment, we're going to use our Bunsen shiny copper colour. So we're going to use our metal tongs to heat this in our Bunsen flame. So change it to a hotter flame. Changed a much darker black colour. This is because the copper metal has reacted with oxygen in the air to create copper oxide, which is a much darker black colour.
Okay, so that's it. So let's go back to our notes. So the last part is to rank the reactivity of the four metals. So just what I have said, sodium should be the most reactive metal because just a tiny cut, it will oxidize. Sodium will be oxidized when it is just freshly cut, okay? So how about these three metals? Actually, we can compare the intensity or the result of the experiment, of the reaction. So for saying there is white light. So for white light, it is quite an intense reaction, and the powder which produced, it will produce hot powder when you just complete the reaction. If you cool down the powder, it will turn white here. So yeah. So for comparison, the white light is quite a strong reaction right here. So same should be the second reactive. So for iron and copper, you can see that for iron there are yellow sparks, and the yellow sparks are quite light. You can see it from the videos, right? And for copper, it just gives you a colored flame. So for comparison, iron should be more reactive than copper. So that's it, the reactivity of the four metal here. So I hope that you have a better understanding on comparing metal reactivity after this lesson, and that's all of today. Thank you, and I hope you enjoy this lesson.